All right, folks, thanks for joining me again for this webinar on Kubernetes. This time, I'm pretty excited to bring you what is called as Ingress. So I hope you're able to hear me loud and clear. In case you have any questions and if you have problems with audio or the screen, please type your question or the query in the questions window. This is going to be a very crisp webinar, primarily focused on understanding Ingress, and I have a couple of demos that I'm going to walk you through, which will explain the concept of Ingress. And walk you through this session. All right, thanks once again for joining me. This session is all about Ingress, and this is also the 12th webinar in the series of Cube.live, which means our first year anniversary. I should thank all of you for encouraging us and supporting us throughout this. We have been bringing you many interesting topics, and as we go along, I'm going to focus more on advanced topics related to Kubernetes. So this time, I'm going to do a quick recap of services in Kubernetes. In case you're not familiar with services, you will get a quick understanding of that. And then I will relate services to Ingress by walking you through the fundamental concepts of Ingress and the key use cases. And finally, I have a live demo where I actually deploy a couple of pods, expose them as node port services, and then configure a load balancer as the Ingress controller. So let's get started. When we look at exposing pods to the outside world, obviously the only way you can do that is through services. In the illustration that you're seeing here, you have a Kubernetes cluster with exactly 3 nodes, and there are multiple pods that are deployed. For visual indication, I have color-coded these pods. So there are a few pods with red, few with green, yellow, and blue. We have also tagged them, for example, with color is equal to whatever color they are representing. So when we actually deploy these pods, they are not available to the outside world. To access these pods, you should be a part of the cluster. That means you should be a part of one of the nodes or the master. And you cannot really talk to the pods outside of the cluster. So to really enable communication across pods and also to the outside world, we need to configure services. So services are required for discovery. For example, if you are deploying a 2-tier architecture and you have a database and multiple web pods, how will the web pods discover the database? So you will first launch the database pod, and then you will configure a service. And this service is going to be used by all other web pods to communicate with the database. Services can be typically of 2 types at a very high level, the most common types. The first one is an internal service endpoint, which is typically used by cache servers or database servers or anything that is supposed to be internal. For example, you will never want to expose your cache service to the outside world. And same is the case with the database. You never want to expose them outside of your cluster. So you will go ahead and configure them as internal services, which are available only within the cluster across the pods. Then there are some pods that need to be accessible from the outside, which means you need to have external endpoints or DNS names or C names or A records configured to these pods so that you can actually have internet inbound access to these pods. So then you'll configure the external service, which will make these pods available to the outside world. In the illustration that you're seeing here, we have actually configured 4 external services called S1, S2, S3, and S4. And using the concept of labels and selectors, we have associated these services with the appropriate backend pods. So when the service endpoint S1 is hit, because of its label selector nomenclature and association, it will route the traffic to any of the red pods deployed in any node. So the concept is there are external services, then there are internal services. Going ahead and mapping them to the actual vocabulary of Kubernetes, the services that are reachable only within the cluster are called as cluster IP. So when you create a service, and this is going to be made available only within the cluster, like database or cache, or any of the internal services that never needs to be exposed to the outside world, you will go ahead and configure them as cluster IP. Services that are going to be made available to the outside world will be configured as node port, and they are typically reachable through the node IP :node port endpoint, and this is going to be available on every node. So if you know the IP address of a node, you can hit any node and give the node port to access the external facing node port service. When you are deploying your pods on a public cloud like Google Compute Engine or EC2 or Azure, you can also configure a cloud load balancer. And this is one of the supported types, which typically uses the underlying cloud specific APIs to provision a load balancer, and it automatically wires the node port to the load balancer. So it will basically automate this step of exposing pods on a node port and then creating a load balancer and manually pointing the load balancer to all the node ports. So that is the step which is required if you're not using load balancer service type. But if you're using that, Kubernetes will negotiate with the underlying cloud provider and will automatically wire up the port forwarding to appropriate node ports running across the cluster. So that's a very quick recap of services. So if you are exposing ports to the internet, basically you're configuring node ports, and node port can be further extended to a load balancer. Now, there are some challenges. For example, one of the classic problems that you would encounter when you are deploying public facing applications on a Kubernetes cluster is creating a new load balancer for every service. So that means if you have multiple services and you want all of them to share a load balancer, it is very difficult. So if you are using the type load balancer in your service definition, you will end up creating a new load balancer for every service. So it's not a very optimal way. Second thing is deploying Kubernetes in your data center on bare metal. And you might already have a physical load balancer like F5 or any other proprietary load balancer. And how would you point that to your existing deployment on the Kubernetes cluster? Third thing is, how do you configure, let's say, SSL termination? And how do you create a very clean mechanism of routing your traffic to appropriate service endpoints without creating a lot of backend cluttered configuration? How can you keep it clean but manage it at a very different level, which is at the edge, which is basically the entry point to your entire cluster? So all these are the challenges when you are exposing public facing endpoints within Kubernetes. To solve this issue, starting with Kubernetes 1.2, the community has started building what is called as an Ingress. So an Ingress is nothing but a collection of rules that will allow the inbound connections to reach the cluster services. What it basically means is Ingress in itself is not a load balancer. Ingress in itself is not a physical representation of an edge device. It's a logical controller that will be mapped to one of your load balancers, either cloud or physical or a proprietary one. And it creates a set of rules. And these rules will route the traffic at runtime to an appropriate endpoint. And obviously, you cannot use an Ingress to route traffic to a cluster IP, because cluster IP is never reachable to the outside world. So if you have a set of pods that are exposed to the outside world through node port, and you want a very clean mechanism to expose them and create a set of rules, then you'd actually create an ingress. An ingress sits a level above service, particularly the node port service, and it is configured to expose services through external URLs. This is the preferred way and a best practice to wire up a CNAME to your service endpoint. So if you want to configure an external URL, using the node port in its raw form is not a good idea. Instead, you should actually go for an ingress and make that as an intermediary between your domain name and your endpoint, so that actually decouples your physical deployment from the logical DNS name. So tomorrow, when you're actually changing any definition, you can just tweak your load balancer or ingress, and the CNAME remains the same. So that gives you a nice clean mechanism of decoupling domain names to your node ports. Of course, a collection of load balancers can be integrated with Kubernetes through Ingress. You can bring multiple varieties of load balancers, including physical load balancers like F5 or HAProxy, Nginx, and a bunch of other available load balancer, and you can very easily integrate that with Kubernetes. And because you have a layer above the services, you can also offload SSL termination. So you can actually handle SSL at the ingress while keeping your node ports out of the picture. So you can basically add your Let's Encrypt certificates or your CS certificates at the ingress level, and that handles the TLS and SSL termination right at the edge level. So you're not touching again the node port. And in some advanced scenarios, you can also do name-based virtual hosting. So if you have ever administered Apache or Nginx, you know what I mean. So basically, you will have the same IP address, but you will have multiple host names. For example, foo.bar.com will translate to a different service endpoint. abc.bar.com will go to a different service endpoint. So you can actually create a very complicated routing logic, which is almost like the way you handle Apache virtual hosts or Nginx virtual hosts, but at the ingress level. So this gives you plenty of room to play with the configuration, create a set of rules, and secure your deployments. So where does the ingress fit? As I mentioned earlier, it is pretty simple. It is a layer above the services. So if you take our existing deployment and throw an ingress in front of all the node port services, your connections will flow via the ingress. That's the idea. So ingress cannot function if you don't have services. Ingress is always front-ending your existing services. It's a decoupling layer between internet and your node ports. That's the best way of understanding ingress. So it becomes very clear when I actually walk you through a demo. So it's time for me to show you a quick demo and walk you through the concepts. I have 3 different scenarios. Let me walk you through each of them. So let me first show you my setup. Since Ingress makes a lot of sense on the public cloud, we are actually using the GKE deployment. So I currently have a cluster configured in GKE. So when I type kubectl get nodes, you will actually see that I have a 3-node cluster running on Google Container Engine. And we are going to use this to create an ingress and also configure a set of rules. All right. So the very first thing is deploying an Nginx pod, exposing that, and then creating an ingress to abstract the backend Nginx deployment. So let's go ahead and try this, the very first demo. So we're going to basically create a pod. It's actually a deployment. So when I say kubectl run Nginx followed by an image and the port, this is going to create a deployment. So now when you actually say kubectl get deploy, you will notice that we just made a deployment of Nginx. You can also get the pods and this shows one of the pods running. That's the Nginx pod. Obviously, we don't have a service to access this, so it is just a pod, which is a part of the deployment. So let's go ahead and expose this. So the kubectl expose command implicitly creates a service. So we are saying expose deployment Nginx on port 80, type is node port, which means this is going to be available on every node. And if we configure the right set of firewall rules on Google Compute Engine, we can actually access that. But that's not the idea. We don't want to tinker with the firewall rules here. So let's go ahead and expose the service. So now when I actually say kubectl get service, we'll see the Nginx service becoming available on port 31117 on every node. So external IP is saying nodes, and this is the cluster IP, and this is the name of the service. But obviously we can't really do anything with it because we can't access the node port directly. We are running in the public cloud. So it's time for us to create our first Ingress controller. So let me open the very first Ingress definition. This is extremely straightforward. So it starts with API version. This is actually an extension, v1 beta 1. So you need to make sure that your deployment supports this. And if you're running Minikube or if you're running a local setup, it's a little bit complex to explore Ingress because you need to actually configure Nginx Ingress beforehand. But it becomes much more simpler to understand if you're dealing with the public cloud, because Ingress will be wrapped around a load balancer, and that gives you a nice mechanism to try it out. So if you have plans to test this on Minikube or your local cluster, then search for the documentation and guides on using Nginx locally as an Ingress. But that's out of the scope of this demo, because I want to highlight the use cases and the workflow rather than creating an Ingress controller within the Kubernetes cluster. We are assuming the Ingress is already there, it is already configured, and GKE comes with an Ingress controller that is wired to a load balancer. So we go ahead and define that. Kind is Ingress, like service, pod, replication, controller. We'll define the API object of Kubernetes as Ingress. The metadata, we just give a arbitrary name. Let's call it Nginx Ingress. Then there is spec backend. So we are actually now creating some kind of a rule that says for this Ingress, look for the name of the service called Nginx. So here we have, so we are basically pointing this Ingress to Nginx, and service port is 80. That is what is actually natively exposed, not the node port, but the internal one. So now let's go ahead and create this Ingress, right? So kubectl create followed by the Nginx ingress.yaml. Okay, so now this is going to create an Ingress. So at this point, let's switch to the Google Cloud Console, GCP console, and let me open the network load balancing tab. And we'll actually be able to see a new load balancer showing up in a few minutes. It's going to take a while. So we already have a couple of load balancers from my other demo. I have some canned configuration because it's going to take a while. So I'm not going to rely on this workflow because I have to spend at least 3 to 5 minutes waiting for the load balancer to show up, and then the internal DNS, and there we go. So now there was a new Nginx Ingress that was created, and obviously this is going to get an IP address. So it automatically gets an IP address. You can test the creation of the Ingress by typing this kubectl get ing, which is the short name for Ingress. So this is the address. Host is star because we didn't put any rule on the hosts. So you can also go ahead and describe the Ingress called Nginx Ingress, and this is going to show us a lot of information. So it tells us that the Ingress controller is now creating a load balancer, and it is pointing to the backend Nginx 80. These are the forwarding rules. So basically Kubernetes has negotiated with underlying Google Compute Engine networking stack to create all these rules for us, the health checks and everything. And here it has gone ahead and wired the load balancer to the Nginx 3117 port, right? Which is what is available as the node port. Now you can basically do a curl. So if you actually get the public IP address, so let's grab this and do a curl to this. It's going to take a while. It's not going to be immediately available. So if you now access this from the browser, you'll actually see a 404, but that's common. It's not a problem with anything. It just takes a while for the records to propagate and the internal DNS to synchronize. So it's going to take a while for this entire table to get fixed. So to actually save time, what I've done is I have pre-configured an Ingress controller. So now I can actually access this. So here is my IP address, and you will actually end up seeing this page when ultimately the load balancer stabilizes and it makes a connection and updates the records to talk to the backend. So that's how now we have a very clean mechanism. So we don't need to put node port here, and we can directly hit the IP address. But if you're wondering, how is this different from a load balancer type that you would create when you are exposing a service? Well, if you are creating a load balancer and not in Ingress, as I mentioned earlier, you will end up creating a new load balancer for every service of your deployment. So if you have two services and both of them need to be exposed to the outside world, obviously you have to put load balancer as a type of service, and that process, that action will result in two physical load balancers, and load balancers will cost you dollars, right? As long as the load balancer is on, it is running, Google will charge you. So it's not a very efficient way of using load balancer in the public cloud. So instead you should actually look at Ingress. So that's the first demo. Now, okay, there we go. So now even our current deployment has come up. So if you actually now do a curl from the command line, you don't see a 404, you'll actually see the Nginx HTML coming out. Fantastic. So this is how we basically wire up the pod to the service and service to the Ingress. So let's actually take a look at it. So now we have a pod called Nginx, which is mapped to the Nginx service, which is further mapped to the Nginx Ingress. And this IP address goes all the way up to this pod. So that's the beauty of an Ingress, okay? Now, the next step is to go ahead and create a static IP address, because currently our load balancer has an ephemeral IP, and that might change. You know, for some reason, if you delete the load balancer or delete the Ingress, you shouldn't delete the load balancer directly. You should first delete the Ingress. If you're going through that process, you'll actually end up getting a new IP address, and then your CNAME will break. A lot of your A records and a lot of things will go for a toss. So how do you avoid that? Well, it's a good idea to first create a static IP. So now let's go ahead and ask. Okay, so let's call this Nginx 1 static IP. So let's go ahead and ask GCP to create a static IP. So now there is a new static IP. So Google G Cloud Compute addresses, and if you type list, we should actually see two different IP addresses. So Nginx 1 is what we just created. It is not in use, it is reserved but not in use. So now what we'll actually do is to use the static IP address for our Ingress. So how do we do that? It's again pretty straightforward. So we add an annotation, and this annotation says ingress.global static IP name is this. So this is a queue for the Ingress controller to update the load balancer with the static IP that we created in the previous step. So let's actually go ahead and wire up the static IP that we just created with the Ingress controller, right? So now this is configured. So if you come back and do a describe, so kubectl describe Ingress, Nginx Ingress, this is going to show us an update, right? So initially when the load balancer was created, it got an ephemeral IP, which ended with 18. After we have gone ahead and created a static IP address and updated the Ingress, it assumed the new IP address, which is this. So let's grab this and do a curl. Obviously, it's not going to be instant. It's going to take a while. Again, we'll actually see a 404. That's because the records need to be updated again. It's going to take a couple of minutes for this to get updated. And after that, what we have is a static IP pointing to the load balancer pointing to the service, and the service is pointing to a set of pods which are a part of the deployment. So now we have a very loosely coupled hierarchy which can be updated independently without touching anything. So this is other mechanism for us to use Ingress with a static IP address. So obviously it's not going to be very different. You know, when this gets updated, we'll see the default Nginx landing page, nothing fancy. So that is the second demo where I wanted to show you a static IP getting associated with the load balancer. Finally, let's actually go through an interesting scenario, right? This is where the Ingress becomes extremely powerful. Now I'm going to launch another pod and another service. And I don't want to create another Ingress because that will result in a new load balancer. And I have two issues with that. The first issue is it's going to cost me money. I want to be frugal. I don't want to end up spinning up a new load balancer for every service. So I want to minimize the cost of creating resources. So I want to have just one. The second problem is I want to have one domain. For example, I have a WordPress instance running as a pod exposed as a service. I have my core front end running as a service. So basically all of them are microservices, and they all translate to things like /blog, /order, /shopping cart, and so on. So now we need to deploy all these microservices as pods, create external facing node ports, and then use exactly one Ingress to drive traffic to any of them based on the path. So when I actually say /blog, I want my Ingress to route my traffic to a WordPress pod via obviously a service. When I say /shopping cart, it should take me to the UI exposed through the shopping cart service. So one load balancer, multiple rules that will basically route the traffic to one of the endpoints. So to emulate that, I'm going to launch another pod, and this is called an echo server. This is coming from Google for the demo. I'm actually using the same because it just makes it very simple. So we are now going to run a pod called echo server, and this will create a new pod called echo server, and we'll also go ahead and expose this to the outside world via the node port. And because we are on the public cloud, even node port is not directly accessible. So now we have two services and two pods. So we just exposed echo server. The internal port is 8080, external port is 30494. And what I want to achieve is create one Ingress, but have both the microservices. In our case, one microservice is the Nginx microservice. The other one is the echo server. Map both these microservice endpoints to the same Ingress. So how do we do that? For that, we need to basically create a new Ingress definition. So, and this is called a Fanout pattern. It's called a Fanout because if you visualize, the traffic will hit the Ingress and then it just fans out to multiple microservice endpoints. So if you actually take a look at this, it is very logical and very intuitively defined. So of course, this is an Ingress kind, some arbitrary name, but within rules, we are defining a HTTP rule that says if the path is root, hit Nginx. If the path is echo, route this traffic to echo server, which is this, and the port is 8080. That's what I'm actually saying. So now, when we actually go ahead and create the fanout ingress, so kubectl create fanout ingress, this is going to create one additional load balancer, right? So when we come to the networking part and do a refresh, we are going to see a new fanout ingress load balancer that will show up, and that is going to be responsible for routing the traffic to both the services. One is echo server, the other one is the existing Nginx, and there we go. So now we have a new fanout ingress that is created. So how does that work? Again, this is going to take a while. So if you come back and do a kubectl get ingress, we'll have two. The fanout ingress hasn't actually received a public IP yet. So okay, in this step we actually ended up getting it. Now if you do a curl, ideally it should show Nginx, but as we have seen earlier, it's going to take a few minutes, and eventually doing this will show us a different output because we are ending up hitting a different microservice endpoint. So again, to save time and to give you a full-fledged experience, I have already created this in my other cluster. So let me grab this. So when I actually do a curl to this, by the way, this is the parallel ingress, which is pre-configured, and this is going to throw the Nginx output. Perfect. So when we actually come here and hit this IP address, we'll see Nginx. Now, on the same, I can actually type /echo, and this is going to show us some metadata, and that contains some default output coming from Nginx, which actually shows what is the client address, what is the path that we are hitting, what is the request URI. So basically, this is the header information coming from Nginx. We are just printing it verbatim. So the idea is we have one endpoint, but when you type a different path, you'll be taken to a different service. So you can create multiple services and bring all of them under the umbrella of an ingress and treat them like an integrated application. So this is a very powerful pattern where you can consolidate all your public facing endpoints of a Kubernetes cluster to one ingress and deliver a seamless experience to your end user. When they actually come to this, they don't even realize that they're actually talking to a Kubernetes cluster. And they will never notice that you're actually creating an autonomous, loosely coupled set of microservices that are extremely loosely coupled. They don't even acknowledge each other. For example, /echo has nothing to do with our Nginx. It's a very different deployment altogether, but we could carefully bring them under one umbrella by creating the fanout pattern. So you can actually repeat this entire demo. There is a fantastic walkthrough which I have followed, and I didn't want to create another tutorial. So if you actually type GKE Kubernetes Ingress, you will end up hitting that tutorial, and it just takes a few minutes for you to repeat whatever I have shown. So basically spin up a new cluster and go through exactly the same scenario. So there are 5 steps. The last step is actually 6 steps. The last one is the fanout, serving multiple applications on a load balancer by creating a fanout ingress. So that's the advantage of using a fanout. Now, if you actually describe the fanout ingress, so not get, but describe, it'll actually show some interesting output. So it actually shows that the host is star because we didn't put a host level rule. So root is pointing to Nginx 80. Echo is pointing to Echo Server 8080, which is nothing but another service endpoint. And of course, it shows the remaining events when the load balancer was created, what's the IP address, and so on. But to check whether the creation was successful or not, you can actually describe your Fanout ingress and make sure that this is populated. And it's an indication that the ingress is now in action. So very powerful concept. And it actually makes your production deployments very powerful and very manageable. So let's come back to the slide deck and finish the remaining steps. Okay, so I want to talk a little bit about how Kubernetes actually manages. So technically speaking, the Ingress is nothing but another kind of a controller. It is actually not a native service object, that you would get with Kubernetes. It's a type of a controller. And when I say controller, in the previous webinars we discussed replication controllers, daemons, jobs, daemon sets and jobs and so on. So like many of those, an Ingress is also a controller. And the other interesting thing is it's actually deployed as a pod. But that pod is a special pod because it's going to watch the API servers /ingresses endpoints. So every time a new ingress request comes, it's actually going to hit this endpoint on the API server, which is a queue for the pod to actually spin up a new ingress. And you will never see that because it runs in a different namespace, and Kubernetes handles that as a part of the cluster infrastructure. So you'll actually never get to see that. But behind the scenes, every time you're asking Kubernetes to create an ingress, you are indirectly talking to a pod and you're making a post to ingresses endpoint. This is fundamentally different from other controllers because it is not, the life cycle of an ingress controller is very different from rest of the controllers. It is designed to be a specialized system level controller meant to handle the special type of a pod called Ingress. So you can read further on Kubernetes documentation. There are also multiple mechanisms for you to create very advanced set of rules at the Ingress. You can explore all of them. But my objective is to give you a thorough overview of Ingress and how to complement services with Ingress. So that brings us to the end of this webinar, and I'm very excited to announce the next one. And as I mentioned, we are moving to advanced concepts. I'm very excited to announce the webinar on building CI/CD pipelines with Jenkins and Kubernetes. And I'm going to show you a pretty powerful yet cool demo of source code to production. So we will basically configure a GitHub repo. We will wire it up with Jenkins, and we'll wire up Jenkins to a Kubernetes cluster. And when we check in source code and commit it, it will trigger the whole pipeline, and your changes will be deployed to a live Kubernetes cluster, and customers or consumers will immediately get to see that. And by taking advantage of Kubernetes deployment and PaaS-like capabilities, you can do very advanced things like A/B testing, performing rolling upgrades, performing canary deploys, and take advantage of Kubernetes native deployment capabilities, combine it with Jenkins, and you can build very powerful, very useful CI/CD pipelines. So that's the theme for the next webinar. This is going to be on August 16th at 9 a.m. PST. So as usual, cube.live will be updated with the recording of this session as well as the registration page for the upcoming webinar. So do sign up for that. It's going to be a pretty interesting one. Now, before I go to the Q&A, if there are any questions, I want to bring up a poll, and I really appreciate if you can take a minute and participate in this. This is useful for us to understand how relevant the webinar was and how you actually rate the content. So I appreciate if you can take a few seconds and click on one of the options. All right, I only see 60% of you voting. I appreciate if everyone who is attending this spends a few seconds and tell me what you feel about the webinar. All right. Okay, so thank you. And one final poll before we wrap it up. So how do you rate the overall quality of the webinar? This is a true reflection of the content, my delivery, the demos and everything. So do let us know what you feel about this, and this will encourage us to bring more valuable, more useful content to you. All right. Only a few haven't voted. I appreciate if everyone can participate in the poll and tell us what you felt about the webinar. All right. Okay, so time for the Q&A. So let me take a look at the questions. So how is Ingress different from a router in OpenShift? To be honest, I have never explored the router in OpenShift. So I will come back to you on that. I don't have an immediate response because I'm not very familiar with OpenShift. But it's an interesting question. I will definitely look into it and see how it is different, or how it is, if it is exactly the same, or did OpenShift absorb the concept of Ingress and expose that as a router. Let me go figure it out and come back to you. How do we access the recording of the webinar? Well, cube.live will be updated with the recording in just a couple of days. So keep an eye on it, and we'll be updating this over the weekend. All right, so that brings us to the end of this webinar, yet another interesting webinar. Thanks again for taking time to participate in cube.live. We really appreciate your participation. Thank you so much, and do stay tuned for the upcoming webinar. Sign up at cube.live. And if you have questions, that's my email ID. Feel free to get in touch with me. I'll be happy to respond to your questions. I keep getting a lot of feedback, a lot of questions. I'm able to respond to a few. Others are in my queue. I will definitely get back to you. Again, thank you. Have a great day, good evening, good night, depending on where you are. I'll see you in the next webinar. Thank you.